This lab exercise, we are going to configure a network using GNS3. So once you have installed the router image, you will find that when you click this button, the router image that you have installed appears here. For this lab, I would recommend you use 3725 router. This area is the design canvas, and we simply drag and drop the networking elements onto this canvas. So let's say we have 3 routers that we will be using. When I double click a router, I have the option of modifying the device settings. So here I can rename it. This shows the image I'm using. We can increase the memory size. These are the expansion slots, so I can choose from a number of options to expand the number of ports that are available on the router. So this is the fast Ethernet connection, and this is the twisted pair fast Ethernet connection. So in my router, I will have each of the slots comes with 2 ports. So it's a way for me to expand the number of ports to 6 on this router. We can connect the routers through this link icon here. So select a router and it gives you a list of ports in which to plug this cable into. So let's just choose the first one here to connect to fast Ethernet 00 on the other port. You can choose any of these ports as long as you remember which one you have connected to, so that you can configure the correct port. Quite often what happens is students can choose one port but end up configuring the other one. So now there is a way to automatically label all these connections without you having to commit it to memory. When you click this button, all those interfaces are nicely labeled. I can annotate the network diagram and give more information about the network I'm configuring. So let's add the IP address labels here. So this is the tool for annotation. So let's say this network is going to be 172.168.0.0/24, and I want this interface on router 1 to have the IP address 172.168.0.1. Now, instead of retyping the whole thing as a notation, what we generally do is just put .1 here. So it serves the same purpose. It tells you that this interface is part of this subnet, and its IP address is 172.16.0.1. This is the last part. Likewise, we can add the address here. So this is .2. This subnet, let's call this subnet 192.168.1.0/30, and here the IP address for this interface will be 192.168.1.1. This interface, let's label it .2. This network becomes 192.168.0.0/24.1.2. Now, as we get around to configuring the routers, we would need to specify the subnet mask, and I would like to make sure that you understand this concept here. So when we write a network address as such, the very first address within this range, that is the network address, and the slash notation tells us how many bits within this network address belong to the subnet part. So /24 means the leading 24 out of the 32 bits is common across all the IP addresses within this subnet. So every IP address that you see here will have the leading 3 octets the same, only the last octet will change. So the subnet mask /24 can be represented as the first, there will be 24 ones followed by 8 zeros. And so this in dotted decimal notation looks like this. So /24 means that the first leading bits are set to 1 and the last bit is set to 0. So the idea here is if you take any IP address within this range and you perform a logical AND with the subnet mask, what you should get will be the network address. You can try this. If you logically AND 172.16.0.1 with this network mask, you should get the network address. That is the whole idea here. What is the subnet mask for a /30 network? So the first 30 bits are all ones. So this corresponds to 255.255.255.252, and only the last 2 bits can change. So here is the subnet mask that you would use for a /30 network. With the routers connected, we are ready to start them. So if you right click, you see the start option which appears here. That's going to start our router. Alternatively, you can hit this button and it starts all the devices on your design pane. Let's proceed to configuring the routers. So when you right click any router, you'll see a list of menu. From here, select console. This brings up the router's console and you can see it is starting up. When the router boots up, you will be greeted by a command prompt. The kind of commands you enter really depends on the prompt you are at. So within Cisco, your router can start off with this prompt here, and you would be required to enable it to change the prompt to a hash symbol, as you see here. At the hash prompt, you can write commands to check the current configuration of the router. We do this using the show run. So this is the running configuration of the router. Any configurations that you do on the router ends up in the running configuration. So as you can see, currently it is empty. None of the interfaces have any IP address attached to it. When a router boots, it applies the configurations which are stored in the start configuration. So this is the start configuration. As we will be executing the commands, these configuration changes will appear in the running config. The problem here is if your router were to be powered off, any changes that you made will be lost. So the way we preserve the configuration changes is to copy the running configuration. This is the configuration that we are modifying to the start configuration. Or alternatively, we can use the command write memory to save the changes onto the memory. To configure the router, we need to be at the configure prompt. So we do this by typing configure terminal. When you partially type your commands, you can press tab to autocomplete. So configure terminal. So pressing tab auto-completes the commands. Note how the prompt has changed. It now shows a config in this prompt, so we can begin configuring. You can use the host name command to change the name of the router. It is currently R1. We can call it router 1. And so you can see how the name of the router has changed. To configure the IP addresses, we have to be very specific about the interface we are configuring. At the configure prompt, I specify the interface we are looking to configure. So interface fast Ethernet 0/0, or alternatively I can shorten, use abbreviated command instead of interface fast Ethernet 00. I can just say int f0/0, and you can see that the prompt has now changed to configuring an interface IF, and in particular we are going to configure this interface here on router 1, the interface which is connected to the 172.116.0.0 network. So the command to specify an IP address is IP address followed by the IP address which is 172.16.0.0, sorry, 0.1, 255.255.255.0, and this has assigned the IP address to that interface. However, the interface is still sleeping. We need to restart it. So when you're typing Cisco commands, one of the things you will realize is that if you want to undo a specific command, you can put a no in front. So there's a command to shut down an interface, and if you put no in front of shutdown, then it starts it up. Now to check that this IP address has been applied, we can look at its status. Note the show command does not work at this level. I need to go up the hierarchy of the command prompts. So I need to exit from here, and you can see the prompt has now changed to config. And again, show command does not work here either. I need to go one level up. So at this hash prompt, I can type show IP interface brief. These are all abbreviated commands. And here you can see F0/0, that is our interface, has been assigned this IP address manually, and it is currently up and running. Let's move on and configure the second interface on router R1. Conf t interface is 0/1. IP address is 192.168. Let's put 0.0 and see what happens. 255.255. So sometimes you might be greeted by this error, bad mask/24 for this address. Now the reason for that is this IP address 192.168.0.0, that is the network address for this subnet, and you cannot assign a network address to any interface. So the specific IP address to this interface should have been 192.168.0.1, and now this should work. Restart the interface. Exit and exit, so I can see now I can verify that both the interfaces are up and running. Always check to make sure that the interface you are assigning an IP address to is indeed the correct one. So 00 should be part of this network, which is on this diagram. Quite often what happens is you have something else on the diagram and the configuration says something else, and this leads to connectivity issues when you eventually check your connections. Just as we configured router 1, we will now configure router 2 and 3 in the same manner. Here's the prompt for router 2. You go config terminal, specify interface. Let's configure F00. Double check to make sure we have the right IP address. So for F00, the IP address comes from the 172 subnet. IP address it's 0.2. Network mask is 255.255.255.0. Start up the interface. So exit out of interface F00, go inside interface F01. IP address here is 192.168.1.0, 1.1, sorry. 255.255.252. IP addresses on router 2 have been configured. We can exit this and double check our configuration. So interface brief. So IP addresses to the interface on router 2 have been correctly assigned. Let's now move on to router 3. Configure terminal, interface F00 has IP address 192.168.1.2. The subnet mask is 255.255.255.252. Shut. Exit. F01. F01 is assigned the IP address 192.168.0.2. Start this interface. And let's go up in this labyrinth of prompts to double check the IP address assignment. So the interfaces are up and running. We are at router 3. Let's test our connectivity. We should be able to ping router 1 and router 2 on the interfaces which are directly connected to router 3. Right, so this works fine. And likewise, we should be able to ping the directly connected interface on router 2, which is 192.168.1.1. So this works nicely. Note the way the network is configured, router 3 will not be able to ping the interfaces which are not directly connected to it. So for instance, router 3 will not be able to access interface F00 on router 1, which has the IP address 172.16.0.1. So why is router 3 unable to reach the 172.16.0 subnet? Well, the reason for that is the routing table on router 3 is currently empty and it has no idea how to reach this network. We will have to configure it. We can do this by static means, where we can explicitly state the route router 3 can follow to reach the subnet, or we can use a suitable routing protocol to populate the forwarding table on the routers. In this lab, we will use the routing information protocol, or RIP for short. So on each of the routers, we will configure RIP as follows. Configure the terminal, router RIP, no auto summary, and specify the version of RIP we would like to use, version 2. So this enables RIP on router 3. Now we need to specify the network which is accessible through router 3's interfaces. So if you take a look at this diagram here, the networks that are accessible to router 3 are the 192.168.0.0 network and 192.168.1.0 network. So these are the networks which are directly accessible to router 3. And that's it. So we are done with configuring router 3. Just to make sure that we do not lose these changes, I will commit it to memory. And in similar fashion, I would enable the RIP protocol on routers 1 and 2. Can double check our running config. So here you can see the interface details are correct, and the RIP information is also showing up in the running configuration. Now it's turn to configure router 2. Router 2's neighboring networks are 172.16.0.0 and 192.168.1.0. done. Again, commit all the changes to memory. So starting at router 2, we should now be able to ping the interfaces which were not directly connected to router 2. So in this case, we are at router 2. In this diagram, we should be able to ping interface F01 on router 1, which has the IP address 192.168.0.1. So now this should work, and likewise we should ping the interface on the other side of router 3, which is 192.168.0.2. Now our network configuration is complete, and we have verified the connectivity between the routers. Let me show you some additional features of the GNS3 software. You can add virtual PCs to your network that allows you to test connectivity. So these are lightweight processors that you can hook up and see how and simulate how your network behaves. So let's create one network on fast Ethernet 1.0 and hook it up to a PC. Let's say this network has the IP address 0.0/24, and in this case F10 has IP address 10.0.0.1, and the PC, let's say, will be assigned the IP address 10.0.0.2. We will need to reconfigure our router. So here we are specifying the IP address for the interface F10. Let's not forget to update our routing table. So router 1 has been reconfigured. Now let's configure PC1 and bring it online. So right click on this PC icon, we start it, and then select console. This brings up the prompt for the PC. You can type a question mark to see all the commands and the help options. So to set the IP address on the PC, we'll use the IP command. You can get more details on how to use this command by typing the command followed by the question mark. So here are all the options. So we can set the IP address of PC1 as follows. The IP address is 10.0.0.2/24. So this starts up the interface with the and assigns the IP address. Let's test the network connectivity. Let's try and reach the far point of this network. Let's say if can PC1 ping 192.168.1.2, which is the interface F00 on router 3. So it complains gateway not found. Well, we did not specify the gateway. Who do you think is our gateway? The gateway for PC1 is the router on its subnet, which connects it to the rest of the network. So here the gateway router is R1, and in particular it's the interface F01 that provides the gateway to the rest of the network. So let's rewrite the IP command. IP address for the PC is again 10.0.0.2 network mask /24, and the gateway address is 10.0.0.1. Now let's ping router 3. So you can see we are getting a response from router 3. Another cool feature of GNS3 is that it allows you to capture packets on any of the links using Wireshark. By capturing the flow of packets, you can analyze the traffic and troubleshoot your network configuration. So in conclusion, the GNS3 software is a powerful platform that not only allows you to draw pretty network diagrams, these network diagrams are alive in that the Cisco operating systems for each of these routers are running in a virtualized context, and the configurations that you do in this environment here can be copied over to a real router, and they will perform the same operations that they do on this virtualized context. So this allows you to design and configure your networks and fully test it before deploying it onto actual routers. So it's a very powerful tool for network engineers to have.